Okay, so let's pick up with cognitive development. Our primary researcher in this area, or our primary theorist, I should probably say, will be Jean Piaget. He was a Swiss, mainly biologist to begin with, but he started observing his children's cognitive development and formulated a theory surrounding what he observed in his own children. Basically, his interpretation of cognitive development is that your biological development, specifically how your brain is developing, drives your intellectual development. And different parts of our brain mature at different rates, and that all of us have sort of our own maturation schedule for our brain to develop. And so intellectual development proceeds at its own pace, in large parts independent of what's going on in the environment. The role of the environment, according to Piaget, is to provide feedback about the accuracy of our individual understanding of the world and how it works. So our experience gives us feedback about whether we are correct or not. He thought the most important kind of feedback was feedback about when we're wrong. So here we have a couple of little toddlers. The one on the left mistakenly believes that she can slide down the same slide as her little toy can. The one on the right thinks that he can fit into the little car that his toy can fit into. These kinds of errors are showing these toddlers things about scale, about how exactly the world works. And they formulate hypotheses, they test them out, and then the feedback that they get informs their future hypotheses. Okay, sorry about this sort of goofy looking table, the way I've got stuff covered up. But I wanted to walk you through Piaget's stages of cognitive development. Embedded in here are a couple of video links. Again, I want to remind you that if you want to watch the videos, all you have to do is open these slides as a slideshow, and then the links will be active and you can watch the videos. Okay, so Piaget thought that we move through cognitive development in a series of stages, and that you'll stay in one stage until your brain matures enough to push you into the next stage. So from birth to about 2 years of age, he said that we explore the world using our senses. So he called this the sensory motor stage, that we move around the world using our senses to understand it. So here's a baby somewhere around 6 months, because she can sit unsupported, right? And they take a little toy, put it in front of her. She's obviously interested in it, see her staring. Then they cover it with a little blanket. In this case, it's a little cloth diaper. This baby's probably pushing closer to 8 months of age, because one of the things that she's displaying is what's called object permanence. She's got at least the rudimentary form of object permanence, and it starts to appear somewhere around 8 months of age. She watched them cover the toy with that cloth and was able to pull the cloth off to reveal the toy. Now that doesn't seem very magical, because no duh, you just saw me cover it and then you pulled the cloth off. How complex was that, right? But what she's displaying is her cognitive awareness that even though the toy went out of sight, it did not mysteriously disappear. It's still there, it's just covered with the cloth. In another couple of months, she'll be able to go a step further, and you can hide the toy from her when she's not looking, and she'll know to look for it. Object permanence develops in stages, and the first stage of it is this one where we hide it in, right in front of you, and then you're able to. 2 months prior to this, she would have, when the cloth got put over the toy, she would have just thought, well, I guess it's gone, and not even looked for it. So this is a big step when she realizes pull the cloth off. Again, if you know any babies, you could try these things out with them, and it's really amazing to watch them make these mistakes until they're ready to not make the mistakes. Another phenomena that occurs during this stage is stranger anxiety. A lot of parents get very concerned about this, especially American parents who want their kids to be outgoing and gregarious, when very normally, somewhere after about 9 months and really peaking by about 15 months, children start to develop stranger anxiety. They don't want to be around people that they don't already know. makes them anxious. They may cling to mom's leg or hide behind her. Mom's saying, you know, give grandma a kiss. I know you haven't seen her in a little while, but she's come all this way to see you. Give her a kiss. And the little 15-month-old is crying and clinging and doesn't want to. That's very normal for babies to not want to be around strangers during that period of time. It's a sign of cognitive development that they realize I should be with people who I know and avoid people who I don't know. The next stage of development encompasses about 2 years to about 7 years of age. I keep saying about very strongly because, you know, these, like I said, they're biological factors that determine when you'll move to the next stage. So it's about 2 to 7 years. During this stage, Piaget referred to children as pre-operational because they don't yet understand how the world operates. So they are they haven't yet reached their understanding of how the world operates. Now, big signs that they have reached pre-operational and have left sensory motor stage is that they now can use words and symbols, images to represent things that aren't currently here. So in other words, once a child learns to talk, they've moved from the sensory motor stage and into the pre-operational stage. They can also use images to represent things. So this is the period of time when kids start to recognize daddy in a picture, or their family dog in a picture, or that is a doggy in the picture, stuff like that. During this period of time, kids tend to be very intuitive and not very logical. We talked back in Chapter 1 about some of the risks of using our intuition rather than our logic. 2 to 7-year-olds are the perfect examples of people who are relying on intuition and not thinking logically. Now the great thing about using intuition is it enables us to engage in pretend play. So you can have 4-year-olds who are playing a very elaborate game of house, and they really seem to take on the roles that they've adopted. One of them really thinks that they get to be the mom, and the other one thinks that if they put a jacket on backwards, that suddenly they're some kind of person whose outfit is not a jacket put on backwards, but suddenly this really makes it into something. Or I remember when I was little, my friend and I used to play dress up with these leftover curtains that were sheer, and oh my gosh, those things could become our wedding veils. They could become our cocktail dress if we wrapped them around and then crisscrossed them in the front and tied them around our neck. Oh my gosh, those were the greatest cocktail dresses ever. We really thought they looked like dresses. Seeing ourselves in pictures, looking back, we were cracking up because we're like, oh my gosh, we have curtains tied around us, and at the time we really thought that we looked good in them. That kind of pretend play, relies on you not being the world's most logical, but being able to use images and other kinds of elaborate mental games. Egocentrism is another factor in this period. Now, Piaget did not meet egocentrism in the self-centered, sort of conceited way that we oftentimes refer to a person who's egocentric or narcissistic as an adult. What Piaget meant was literally the kid between 2 and 7 years of age really could not take another person's perspective. Here's a classic Piaget experiment where he's got a 3-dimensional model of a mountain, and as you can see from the angle, we're looking sort of the same angle that the little girl is. You can see a cross on the peak of one of the mountains and a little house on one of the other mountains. Each angle that you view that mountain from has different landmarks. Like one view might have a deer, a little toy deer on it, and another one might have a waterfall or something. Different things that can only be seen from one angle. So the little girl gets a chance to go and view the mountain from all 4 sides, and in fact she's encouraged to name all the things she sees from all 4 angles. So we know she saw the stuff that's on the other angles. Then you place her on one side, and you place Dolly on the other side, viewing the mountain from a different angle. And you ask the little girl, what is Dolly seeing? And the little girl will name off what she is seeing, not what she remembers having been on that side of the mountain that Dolly's looking at. That's a perfect example of what Piaget considered egocentrism. Even though the little girl probably is capable of remembering what was on the other side of the mountain, she literally believes that she and Dolly are seeing the same thing. That literally her perspective is Dolly's perspective. And that's what Piaget meant by egocentrism. They literally, children think that if they can hear it, everyone can hear it. If they can see it, everyone can see it. If they know it, everyone knows it, which is one of the reasons why littler kids, 2 to 5 for sure, really don't lie very often, because they figure that if they know it, you know it. So what would be the point in lying to you about it? You're obviously not mad, so you know, it's just a known fact and you're not mad about it. So it's not until they're about 5 years of age that you typically, in most kids, will see this shift where they suddenly become aware that they know things that you don't know, and then they can kind of use it. Like I already mentioned, mastering language is the quintessential piece of evidence that you have moved into the pre-operational stage. So, all right, let's move to the next stage, which encompasses about 7 to 11 years. It's really from the end of pre-operational to the beginning of puberty, according to Piaget. He called this the concrete operational stage. In this stage, you understand how the world works, how the world operates, as long as you are dealing in concrete events, things that you can touch, things that you can interact with directly. You're not going to expect a 7 to 11-year-old to display great hypothesis building or hypothetical reasoning or ability to really understand possibilities and things like that. Big things that are happening during this stage, they do start to understand analogies. Not perfectly. Us as adults, we're not perfect with analogies. If you've ever taken the SAT, you know what I'm talking about. Analogies are tough, but this is when kids start to understand that when somebody says, it's like a rose, that you mean that it smells good, that it's colorful, that it's a plant, you know, that you can start to understand similes for sure. This is a point when kids start to understand arithmetic also. They can start to do addition and subtraction, multiplication and division. They start to understand the logic of the rules, as long as it's concrete. And a lot of times with kids, you start introducing those concepts with like beads, and they pile them up and count them, and you know, these kinds of things. Make it a very concrete task rather than something that they're supposed to be doing in their heads. They do really well with it as long as it's concrete. Now, one of the ways that we can tell that you are in the concrete operational stage and no longer in the pre-operational stage is that you start to display evidence of conservation, where you understand that even though something may look like it's changed, that it has actually conserved its basic properties. There are some video toolkits in the Launchpad series that have conservation as an option, and you can watch little kids doing this. I have a video of my daughter doing it. She's 4 years 3 months old when she does it, and it's just shocking that you can take 2 glasses of water that are the same, and then right in front of the child say, watch me while I pour this, and you pour the water from one of the 2 glasses into, let's say, a taller, skinnier glass. So now the water level is going to be higher once you've gotten it into the new glass. And you ask, is the water still the same? They really don't think it is. They think now that it's higher, there must be more. They really don't understand that the central property of volume is conserved, even though the objects look different now. It's a really shocking mistake that kids make. They make these mistakes for volume. They make it for when they're little, like 4. They'll do it for number. If you have a row of pennies and then spread it out and put spaces between the pennies, they'll think there's more pennies, even though all you did was move them. It's a little bit of magical thinking. They'll agree that they did not see you add any water or add any pennies. They recognize that you didn't do anything like that, and then you'll ask them, well, then how is there more? And they'll say, because you poured it into the other glass. Like the act of pouring makes a magical change in the fundamental characteristics of the water. You can't, this is one of those areas where Piaget's notion of biology is really profound, because you cannot explain this to a child and have them correctly apply it 2 days later with a new test of conservation. In fact, there's an example in your project list. If you want to test this out on a child, you can try testing their conservation, their egocentrism. And the thing is, it doesn't matter how much you explain it to them. And they may be able to parrot it back at the moment. My 4-year-old, when I tested her, she recognized that there was the same amount of pennies, even though I had spread them out. And she was able to verify that there was the same amount because she counted them. But then the next time I tested her and I spread out the pennies, even though she had explained to me that the pennies were still the same last time we tested it, she got it wrong that time. Something about the way that I had set it up, the way I had spread it, removed whatever concrete thing was she was focusing on the first time when she got it right. And she was back to the pre-operational kind of logic. She hadn't reached it yet. She was only 4. Once you're between 7 and 11 and you get conservation, it sounds like such a stupid question to show a child a row of pennies, spread it out, and ask if there are more. They're like, no, why would there be more? All you did was spread it out. I mean, they just don't understand why you're even asking this question. No, there's not more Play-Doh just because you smashed it. It's the same Play-Doh. What are you asking me? It's that awesome period when they're in the pre-operational stage where they really don't understand conservation of volume, mass, number, those kinds of things, area. This doesn't just like one day leave us and suddenly we get all sorts of conservation. Even us adults still make conservation errors. Companies can kind of trick us into thinking that we're getting the same amount of ice cream, even though they used to sell us, let's say, Dreyer's ice cream used to sell us ice cream by the gallon, and now it's like less than 3/4 of a gallon. But it doesn't look that much different. They've sort of manipulated the diameter, the height of the cylinder of ice cream, and it's hard to tell that it's changed because those kinds of subtle transitions. It's hard. Mass is hard for us to correctly recognize. But the beginning of conservation is when we know you've transferred over into concrete operational thinking. One of the things about conservation is it enables us to do math transformations that for the pre-operational child is like a new problem every time. If you know any first graders who are just learning addition or subtraction, you'll notice on their math worksheet there might be 1 plus 2, and then later there is 2 plus 1. Now for us adults who know math, those obviously are the same question, and you shouldn't have to put any thought into the second one because you already solved the problem on the first one. But for pre-operational children, they think 1 plus 2 is literally different from 2 plus 1, and they will spend just as much cognitive energy trying to solve that math transformation. When you're in the concrete operational stage, you recognize that things can be reversed. That if 1 plus 2 is 3, then 2 plus 1 is 3, and 3 minus 1 must be 2. And 3 minus 2 must be 1. I mean, you start to see that it can be reversed, and it becomes a really simple process. From puberty onward, Piaget thinks that we enter our full-fledged formal operational reasoning where we can think about abstract problems, we can think about hypotheticals and possibilities and things like that. So we've reached our adult cognitions. Now, anybody who is listening probably recognizes that you reached puberty and that you continue to still develop cognitively, and that you probably still will be, probably our whole lives we develop cognitively. But for Piaget, once you reach puberty, with the addition of those sex hormones, your brain takes on its mature form, and that's it. You are in your ultimate form, according to him. So from puberty onward, we should expect children to be able to deal with abstract questions such as, what would it mean for you if your mother had never been born? Anybody who's reached full formal operational reasoning knows that if your mother had never been born, you couldn't have been born. When I asked that question of my concrete operational Girl Scouts, they all had really interesting answers, but only one correctly reported that she couldn't have been born if her mom hadn't been born. And she was a little cognitively advanced compared to her peers. The rest of them were saying things like, I'd miss her, or I'd miss Uncle Pete, who must be Mom's brother, or I wouldn't have to go visit her dad in prison anymore, which was an interesting thing for my Girl Scout to say. I did not know that she had a grandfather in jail. But none of them, except for the one, correctly recognized that abstract issue, which is without your mom's input, you could not physically be you, right? So once you reach formal operational, then you understand abstractions like that. Also, you develop, according to Piaget, the capability for mature moral reasoning, like the ability to judge right from wrong and things like that, which we'll talk about a little bit later. So for Piaget, once you reach puberty, you reach that ultimate ability to reason. If you take lifespan development, we talk about this whole concept in a lot more detail, and you realize that actually most modern researchers don't think that you reach mature moral reasoning or cognition at puberty. But we're talking about Piaget, not like what's for real. So that's what he thought. This is how you proceed through your stages of cognitive development. And each of those stages has its hallmark that lets you know that you've moved to the next stage and have left the other one behind. Okay, let's go ahead and take a little break here, and we'll pick up with something else that Piaget introduced, which is the concept of schema.